Okay, so we are now recording, and I need to share screen. Okay, so I'm gonna start the Jupyter node. I'm gonna start the Jupyter basically Anaconda. So remember, we're gonna go here, all apps, and then Anaconda, and then I usually start with the Anaconda prompt. Okay, and this is section 1. So we're going to do that. Also, I'm going to DIR. I'm going to go to the desktop. DIR. And then I can't remember if I created. Yeah, it's not, I didn't create a folder, right? So let's create a folder. I think I did it for the other section. So this is probably fall 2023 S2. So then you guys are going to be, so I'm going to create a folder here. ITS 520 fall 2023 S1. Okay. All right, so I've got the folder now. So I'm going to go back to the prompt. Yeah, everyone with me, guys? Everyone with me? Yeah. All right. So there we go. So now I'm going to CD into that one. ITS 520 full S1. There we go. So there should be nothing in here because I just created it. Now, what was the next step? We have to start the Anaconda environment, right? So I'm going to do, so by now you should know these commands, conda environment list. Now I already have these environments. If you're on a desktop, you may need to create it again today, right? Or if you have your laptop, then you should be good. So remember, Pi37 ITS 521, right? So that's the one. So now I'm going to do conda activate Pi37 ITS 521. All right. And so you can see that the environment is already there. I had already installed a whole bunch of things. So I can just start the Jupyter notebook. Okay. And that's how we begin. So we begin our journey, right? To PyTorch. You should feel so lucky that you have PyTorch. All right. So we are going to begin. Today, we're going to do some very basic stuff. Okay. And like I said, the nice thing about this is it really builds. So I've already planned out. So we'll be doing basic stuff the first few days. Then we're going to do regression. Okay. And that correlation coefficient, all that stuff that I showed you. Then after that, we're going to do classification with the which is where we're predicting a class. So we're going to do iris and MNIST. And then that gets us, once we do that, then that gets us ready for the advanced algorithms, such as CNNs and those kinds of algorithms. But that it will take a while, right? Now, my goal with this class is that, as I said, I have a 530, ITS 530, which is the pre-trained models class, right? And so this one is then like the from scratch class, right? So look at all the different algorithms. We will get as far as a GPT algorithm. So we will look at how a GPT, like the part of Chat GPT, right? So, and you'll see that it's similar to what we're doing here, just much more complicated, right? But it's the same ideas, object oriented, same models, same elements, I should say. Okay. All right, so that will be obviously, that's pretty much the end of the class when we get to that level. But we will write it from scratch. Okay. We will not be able to have a chat GPT because it's not just the algorithm. You guys see that, right? It's the data. We have to have tons of data, and we'd have to have a ton of computing power and time, which we won't have. All right, so let's go ahead and start. So I'm going to hit, remember, Python 3. And then I'm going to just begin with the very basics. So the things that we need to understand how to do is, how to read data, how to create tensors, and then how models, how do you get an inference function? How do you train that inference function, and so on, right? So those are the basic elements. So I'm going to go ahead and do this. Okay. Now, remember, all this code is already available to you, so you don't have to worry if you miss something because it's all on the repo, right? If you go to PyTorch, remember, that's where I'm getting all of these from. Okay. Right, so we're going to build our very basic one. So we're going to start with the script called basics torch. Okay, we're going to do a few tensors, and so on. Okay, so let's start. We need to import the libraries, right? So we're going to import torch, obviously. Import torch. And then import NumPy as NP, right? So if you remember that we had installed all of this last week, so you can always refer back to the video. So right when you run this now, they should be there if you've installed them, okay? Yeah. I mean, I'd love it for you to, I don't know how to turn them on though. How do I do that?
It should be on your little keypad. On the right hand side.
They were on the last.
Yeah. It's normally the keypad thing up here.
The keypad?
Or like a touchpad. Oh, it's behind you.
Okay.
Should be over there. Yeah. Can't see them yet. Oh, it's plain white whale system starting out. Technology, it should be,
Yeah.
and then document PC, power blank, system off. Huh. It should automatically have the others. There it goes. There you go.
Oh, perfect. There you go. Good job. Yeah. Zoom in? Yeah, sure. Like that? Yeah. All right. So again, just like we did with NumPy, we're just going to create some remember the NumPy array here in Torch, they're called tensors, but it's pretty much the same thing, just a different data structure. At some point, we're going to read data with pandas, convert it into a NumPy array, and then from a NumPy array into a Torch tensor. Okay, that's just so that we can, everything needs to be a Torch tensor as we are building a Torch model. We cannot attach a NumPy array into a Torch graph. It's not going to work. So we need to convert it to a Torch tensor. Okay, so let's go ahead and create a variable here. So we use the word torch. And then here I'm going to do just like with NumPy, ones. And then of size 3. Okay, so then I'm going to just print A. Okay, hit run. And you can see I've created a tensor basically of all ones, and there's 3 of size 3. Okay. Now, what else can we do? Let's assign to the last value in this torch tensor a number. So for instance, 17.0. Okay, so now that when we print A, let's see what happens. And you can see we've added 17 to the tensor itself. All right, let's now, one of the things that we were doing last week is we were taking lists in Python and converting them to NumPy arrays. Now we're going to do the same with Torch. Okay, so I'm going to create a list here. Remember that's square brackets. 4.0, comma, 1.0, comma, 5.0, comma, 3.0, 2.0, 1.0. Just a list, right? And then we are going to convert it to Torch. We run it through a Torch function. Now, it's a good practice sometimes in your code to do something like this. If you have B, then you want to do B underscore T to indicate that it is now Torch in that format. That's actually helpful. So then let's invoke Torch dot tensor, right? And we're going to feed to it B. So if we now print B underscore T, it will be a Torch tensor. I need to make it smaller so I can find the run button. And you can see it is now a Torch tensor. This is sometimes that I've gotten confused in the past, even especially when I'm doing like a much more complex algorithm, that I try to load like a NumPy array or something into Torch, right? And everything needs to be in Torch to work. So this is going to be pretty important conversions to Torch, basically. Okay. So let's see what else we can do. Let's do a two-dimensional matrix, basically. So something similar. So if you notice, I'm doing similar things to what I did last week with NumPy. So I'm going to do C here, and I'm going to assign to C a list, which is basically a list of lists in this case, matrix. So I'm going to say 4.0, comma, 1.0, comma, 5.0. Oops. Remember, don't forget the square bracket. So 5.0, comma, 3.0, and then one last one. Gonna be 2.0, comma, 1.0. All right, this is a list. Now we're going to convert it into a Torch tensor. So let's add the underscore T, Torch dot tensor, and the variable C. Okay, so we're going to print this one out. C underscore T. Okay, make it smaller, run, oops, run. And there you can see we've created our tensor, basically. 3 rows and 2 columns. Could be some data, could be something. Yeah, please.
For your inside person, is there a reason you put some spaces, or is it just your habit?
It's a habit. These, sorry, yeah, these are habits of mine. Yeah. I like, it's more readable for whatever reason for me. Yeah. So it's a habit, yeah. Good question. Any other questions? You want to see the shape? The shape of them? Oh, reshape it to what? Yes, we can. Yes. So, well, I mean, it's gotta be like, you can reshape it to a vector, for instance. So something like CT, I think it's dot reshape -1. You mean like that? Yeah, so yeah, that brings up a very good question, right? So intuitively, what they're trying to do is they're trying to make Torch and NumPy and TensorFlow have kind of similar things, so that if you, like you said, I've done this in NumPy, can I do it in Torch? And the answer is usually yes. Sometimes the names are a little bit off, but in general it works. Here I just said I wanted it to be one dimension. The -1 lets it figure it out. Okay. Got it, guys? Yeah, you can do such things. All right, we may also want to print out the shapes. Okay, so for instance, I may want to print out, let me actually get rid of this one. Just comment it. Okay, so I'm going to rerun this. All right, and now I want to print out the shape of C_t. So I'm going to do print, and then C_t dot shape. Okay, so it should be 3×2, and you can see that there. It's always a good recommendation to check the dimensions, right? It's one of the most useful things. Okay. All right, let's create a couple more, just like we did with NumPy. Let's create D here, D_t. And this is going to be a torch zeros. Torch zeros, size 3,2. Okay, and then we can print it out. Everyone with any questions, guys? Questions? So D_t, right? Notice that here we directly created this tensor, and there it is, right? So it's made of zeros, and it's 3 rows by 2 columns. Okay, pretty much what we've done before. Let's add a value to this one. So I'm going to index here, and I want to add at row 0 and column 1 the value 17, right? So then I'm going to say D_t 0,1, right? And I'm going to assign to it the value 17. And then, of course, we print it again, so I can just copy this one. And there you go. Do you see that? All right, so now one of the concepts that was the most important, if you remember, I said from the NumPy exercises, the two, we're indexing and slicing. So hopefully you've gone through the slicing examples in NumPy, right? And I want to slice something, right? I want to slice a row. Like imagine a cake, right? And we're just going to slice take a slice out of the cake, right? So that's what we're going to do here out of this. So I want row, and actually let's add 14 to row 2. You see that? So I added 14. So that's the row that I'm going to try to slice. So how do I do that? So let's think about it. All right, I'm going to say print. Obviously, it's D_t. Now to slice, remember, you put in the square brackets, okay? And then you need to tell it. So if I want the row that contains 14, what would be the syntax for slicing? These are exam type questions, right? So I'm going to give you problems like these. So how do you slice this? This has to be, you have to become really good at this. All right, so, huh? One, okay. What else? Colon, okay. I want the row, yes. One colon. I'm going to try that one.
One column.
One. Comma. Yeah. Okay. Yes. Why though?
So a column means all the elements.
Sure. From, well, yeah, a range, right? From beginning to end. Yeah.
So one means
That specific one. Very good. So yeah, and they start at 0, right? So then we wanted this row over here. So 0, 1, 2. So 1. And then we just say from beginning to end all the columns. Got it? This is really important that it's really, really important that you should master this skill. And that's why I gave you the NumPy examples, right? So if this was still shaky for you, go back to those NumPy examples and redo them until it's not. Okay? All right, good. So let's, if we want to index, let's say we want to index 17 out of there. So I'm going to do print D underscore T, and then how do you get 17? 0, comma, 1, right? And that gives you 17. The value, notice it's still a tensor, even though it's a value 17. So it's a scalar, that's what it's called. Keep that in mind. The data type is important. All right. Now we're gonna do something called unsqueeze, right? And unsqueeze is basically whenever you want to add like a new dimension to an array, right? For some specific reason. So basically it adds, you know, a good way of looking at this is to look at the shape and then look at the shape after the operation. Okay, so let's take dt new, let's say, and it's going to be equal to dt. But now we're going to try to add a dimension. Okay, so the way that we can do this, there's several ways, but we kind of tell it to infer these, right? And then we want a new dimension here called none. Okay, so now if I print the shape of dt before, or the shape of dt, we just want to see what happens. So dt dot shape. Okay, run. So we know it's a 3x2. And then we do this operation. Okay, and now we're going to print the shape of this one. New, right? Dot shape. What did you notice? What do you guys notice? It's got this new dimension now. See, whereas 3x2, this one is 3x2x1. Why do you do this kind of thing? So imagine that we had images that are 28x28, right? But we're going to feed into the algorithm a batch of those images. So we don't know what we know in machine learning. You always, to be more efficient, instead of giving it one image at a time, we may give it 32 images at a time. So that tensor is of what size? It's a 3-dimensional tensor now, right? Because it's 28 by 28 by 32, right? There are 32 images of size 28 by 28. What if you want to do an operation of that batch by one other thing? So then you would do 32 by 28 by 28, operation 1 by 28 by 28. So 1 by 28 by 28 would represent one image, but in that batch configuration. Okay, here in this example I put the number at the end, but I could have just as easily done this. Let's call this one new 2. Like that. You see that? So you can play with where you put things. So then we're going to print the size. This is 2. What do you notice there? You see that? So this is 1 3 by 2. The other one. So these are things these are hard things. Okay. So these are the kinds of things that sometimes confuse you about machine learning. Okay. So these are the kinds of things you kind of have to work out, but it's necessary every now and then to do these kinds of things. For now, we don't have a scenario where we're using it, but I'm just showing you how to add more dimensions to your tensors, basically. We made this from a 2-dimensional to a 3-dimensional. Sure. We humans are limited by 3 dimensions. Math is not. Yeah, so there's, hyper dimensions. It's totally works. I mean, it has to, because let's say that you were doing color images. So you have a batch of 64 images, but they're color. You see, so you need to have the R, the G, and the B. So, and what if it's video? Even more. And it can totally be done. Okay. Any other? But I mean, those are hard things. Okay, so don't think that it's just like you should know it. You shouldn't. So it's tough stuff that you really have to think about. And like I said, that's why they pay you the big bucks, right? To know that in particular. People can do the rest, but that stuff is the hard part. All right. Any questions so far, guys? So really, right now, you can see it's a lot of, if you ever played with Rubik's cubes, you do the, that's what we're doing. You're like playing with Rubik's cubes, but these are like abstract Rubik's cubes of data. But it's very efficient to be aware of how this works and to kind of just go through the muscle memory of it all, if you will. Okay, so let's keep going. All right, so we did adding a dimension. Now we're going to create a so this is going to mimic a color images batch. Okay, so I'm going to do batch tensor. And I'm just going to initialize it with random data. So it's going to be torch dot rand n. And then I'm going to do, let's say 8. So that means a batch of 8 images, basically. 3 for RGB. So, and then the actual grid size. So let's say 5 by 5. So that means that our data is images that are 5 by 5, but they're in color. So there's 3 5 by 5 grids, and the Rubik's Cube has 8 of these, 8 samples. So there are 8 images of color of size 5 by 5. Does that make sense, guys? Okay, so you can see that there. That's the data itself. So if you sometimes want to see the data, although this is not always so useful, right? Because these are small relatively, and it's already very hard to interpret, you see? So it's sometimes better just to print out the shape. You can see that there. Got it? Intuitively, this should be 8 images that are 5 by 5, but there's a 3-dimension because there's the R, the G, and the B. All right, so let's do. Let's do one where it's data type. So let's call it data type tensor, so underscore T. And then this is just to show how you can initialize them. So torch dot ones. And then we specify the dimensions. 10, 2. And then here you just specify the data type. So it's D type usually. So it's whatever you want it to be. So it could be like torch dot double, for instance. There's several ways of coding this. This is just one example. Okay, and although we can't really see the effect of this, we can print the data type, for instance. So I could say data type, data type underscore T dot D type. Okay, so if I run, and you can see it is a float 64, basically, which is, that's the data type that you've selected. Okay, as I said, usually you don't use float 64, you use like float 32, and that's more than enough. Because if you do this, you're consuming more RAM memory, so it might be an issue. Okay, any questions, guys? Okay, let's do a matrix of all ones. So A equal torch dot ones. Provide the dimensions 3, 2. Print A. And you can see it's a tensor of different dimensions. Now, interoperability, it's pretty important. And that's the idea that a lot of the time, like I like to do this. I don't know why, if it's a habit or what it is, but I'll read some data in and I make it into a NumPy array first. And I think it's because I like to process, like if I have to do additional processing, I do it in NumPy. And then I only convert to Torch once I know it's going to go into the model. Do you guys see what I'm saying? So, so this is kind of like, I guess what I'm used to, because I probably know more NumPy functions than the Torch ones, right? So it's a convenience thing. But this used to be really hard to do. And now there's interoperability, which is the idea to kind of quickly convert from one to the other. So let's do this one. We will do this. So this is a common thing that happens, like, I've done some processing, I got my results, and then I want to calculate the metrics. So I just, from a torch, I detach it from the graph, convert it to NumPy, and then I process it. Because the thing is also, you have to detach because when things are in the graph, in the torch graph, every time you do something, it's like it processes the whole thing. And so We'll see later on that one common practice is to take something, detach it from the graph, and then convert it into something like a NumPy array. All right, so that's what I'm going to do now. Let's call this NumPy interoperability. Okay. I'm also going to make this cell like a markdown cell. Just to remind you that you can do this, right? So you can do that. So let's go ahead and create, let's call it points. I think that's what's in the example. So points equals torch dot ones size, let's do 28 by 28 by 28. So you can print points here. So if you run, right, that's our matrix there, points, you can see that. Look at what it, what it looks like. Let's actually make it smaller because it's kind of big. Let's just do 8 by 8. Right, so it's easier to visualize. So you can see it says tensor. That's a dead giveaway that it's a torch tensor. Now I want to make it into a NumPy array. So it's very convenient. Points. And notice I'm going to do the same thing I was doing before and just do underscore NP. And that's just helpful. You don't have to do it, but it's helpful to kind of know the data type. And then you just take points, which is a tensor, and you do something as simple as NumPy. This, just maybe a couple of years ago, was not available. And it was very hard to do these things. But now it's pretty easy. So points NP has been created. Now you can print it. So it's going to be points underscore NP. And do you see the difference? Doesn't say TensorFlow, or sorry, tensor. And also there's no commas, right? So this is you have to kind of like get used to what they look like. This is a NumPy array. This is a torch tensor, okay? Pretty important. All right, let's add a few more cells here. Okay, so now, okay. Yeah, there's some information on serialization there, but we're not going to worry about that for now. Okay, so I've gone through the first example of so let me go over here. Go back to the Zoom. Okay, so I completed trying to move this bar. Yeah, there we go. All right, so I completed basically one of these. Okay, so I just want to point out which one. So if we go back to the GitHub, go back to PyTorch, I'm currently here, right? So this is the repo for the class, okay? And we are at this segment here. So if I click on it, I'm basically just going through these examples that you see here. And we just completed basics torch, okay? So hopefully you were following along. If you didn't, do this at home. Again, it's not homework, but practice these. And that's the exercises that I just finished, okay? So now we're going to move on to more advanced things. So if you notice in here, there's one script for reading data. So we're going to be reading in some data. The data is, if you notice, there's a data.zip file here. This contains basically some of the files that we're going to be using to read in. And then after that, notice I have a few scratch learning examples, and this is, now we're done with like tensors and you know, playing with arrays, and we're gonna start now getting into machine learning and dealing with data, building an inference function and so on. Got it? Any questions before we move on? All right, so now I'm going to start with another one of these. Okay, so I'm gonna go ahead, stop sharing. I'm going to stop the video